All right, so let's work on our multiplication of matrices. We're not going to multiply the corresponding elements. And remember, corresponding elements just means that it's in the same place in each of the matrices. And you need to remember that order of multiplication matters for matrices. It's not commutative. So with our numbers, we know that 3 times 4 is the same thing as 4 times 3. Both of them get us 12. But with matrices, AB does not always equal BA. It can, but not always. Okay, so sometimes it works, sometimes it doesn't. But you need to remember that it's not guaranteed that AB is equal to BA. Okay, so order does matter. To multiply A and B, we say that the order of A must be m by n. And remember, this is rows by columns. And then the order of B must be n by p. All right, I know that's really confusing. So let's say that we have A as my blue matrix and B is my orange matrix. Okay, so we're saying that A must be m by n. So rows by columns. And when we multiply that by B, we're saying that the two numbers in the middle need to be the same. If they are not the same, then you can't multiply them. So the number of columns in A has to equal the number of rows in B. Otherwise, just put the dimensions right next to each other and see if the middle two line up. If they don't line up, you can't do the multiplication. But if they do line up, they are the same. What's left on the outside is going to be the dimension of our product, the dimension of our answer, which is the result of A, B. It winds up being m times p, or m by p. And remember, RC cola, rows by columns. For those of you that like to color code, bust out your colors. I'm going to make A my blue matrix, and B is going to be my orange matrix. Now, before we can multiply A times B, we need to make sure that we can even do the multiplication. And to do that, we need to check the dimensions. A has dimensions of 2 by 2 because it has 2 rows and 2 columns, which I've labeled R1, R2, C1, C2. And B is the same thing. It's a 2 by 2. So when we're checking to see if we can even multiply A times B, we line up their dimensions and make sure that the middle numbers are the same. If the middle numbers are not the same, you cannot multiply. But since they are, we take the outside to get the result of our final multiplication answer. All right, we're going to wind up with a 2 by 2. Let's go ahead and get into this. I'm going to write A first, 1, -4 across the top, -5, 2 across the bottom. And we're multiplying that by B. Remember, order does matter. So A times B. And remember, we're doing rows times columns, RC cola, which means we're going to need the rows from A. So I'm labeling the rows, and the columns from B. Okay. Our answer is going to wind up being a 2 by 2. Now, you don't have to do this next step of work, but it does help a bunch of my students keep their work organized. We need a 2 by 2. So I just drew a 2 by 2 box. It's a matrix without the lines on the outside. If I were to label each of the entries, or each of the rows and columns, we know first we have row 1. So each of these placements, or each of these elements, are in row 1. In the bottom, they show up in row 2. And leave yourself some space in between these labels and the lines, because we're going to do the work here in a second. Also labeling our columns, we know anything on the left side is in column 1, and anything on the right side is column 2. You may be wondering why I'm labeling the entries for our answer matrix when we don't even have the answer matrix yet. But this is going to help with our multiplication. It tells you in the top left corner, you need to take row 1 from A times column 1 from B, or row 1 from the blue times column 1 from the orange. And we're going to multiply in the order that they show up. So we're going to have 1, which came first from the blue, times 2, because it came first in the column of the orange, plus because it's always plus. -4, because that's what comes next in the blue, times 6, which came second in the column. Let's try the next one. We need to take row 1 times column 2 of the orange. So row 1, we're starting with 1, and we need to multiply that by 3 because that's what shows up first in the second column. Plus because it's always plus. We have -4 showing up second in our row, or last in the row, times 0 because that is the bottom or the last entry in the second column. Because we have taken row 1 times both column 1 and column 2, we've gone all the way through the B matrix, the orange matrix, we're done with row 1, which means we need to go to row 2. RC COLA, we're going to take row 2 times column 1. It has to be row 2 times column 1. It has to be RC COLA. We're going to have -5, which came first, times 2, because 2 came first in the column, plus because it's always plus. 2 came next in our row, times 6. Now, if you notice what's in parentheses from the columns lines up. My orange numbers line up. If they didn't, we made a mistake somewhere. We need to go back and find it. One last multiplication to do. We need to take row 2 times column 2. So we're going to have -5 times 3, because 3 came first in the second column, plus because it's always plus. Next number in our blue row is 2, and we need to multiply that by the last number in column 2, which is 0. And again, you can double check that they lined up. Okay. All right, we need to do the arithmetic, and you're allowed to use your calculator on the arithmetic, but you do have to show this work manually. You cannot just have this blue and orange matrix on the left side and give me an answer and say a miracle occurs. That's not how it works. Okay, so let's do the arithmetic. In row 1, column 1, top left corner, 1 times 2 plus -4 times 6 should get you -22. Moving across the top row, so row 1, column 2. We have 1 times 3 plus -4 times 0. You should get 3. Bottom left, we have -5 times 2 plus 2 times 6. You should get 2. And bottom right, we have -5 times 3 plus 2 times 0, which gets us -15. And notice that we do have a 2 by 2 result. And we just found A times B. Double check your answer in the calculator. I've posted a video for using the Desmos matrix calculator, a double check. Again, you can check your answers in a Desmos calculator or a regular calculator, one that does not show you all of the steps, but you have to show your steps. Let's try the other way. This time we have B times A. And you need to get into the habit of checking if you can even do the multiplication by checking the dimensions. And I'm going to keep the same color coding. So I'm taking the 2 by 2 orange matrix times the 2 by 2 blue matrix, which means that they are good to go, and our result is going to be another 2 by 2. This will not always happen. And if you keep up with the matrix multiplication videos, you're going to find out this definitely does not always happen. But we do get to multiply B times A. So I'm going to go ahead and write that with my color coding. We have the B matrix of 2, 3, 6, 0 in orange times my A matrix of 1, -4, -5, 2 in blue. And remember RC cola, we're going to be using the rows of the first one and the columns of the second. And since our answer is going to be another 2 by 2, I'm going to go ahead and put in my little breaks here, set up a nice way to keep my work organized. Remember that the top is all about row 1, the bottom's all about row 2. I'm going to label these because it's going to help with our multiplication. And then our columns, first column of the matrix, second column of the matrix. So on the left side, we're going to have column 1, on the right side, column 2, and we're ready to do our multiplication. We're going to do RC cola, so row times the column. We're going to have 2 times 1, because the 2 and the 1 both came first, plus, because it's always plus, 3 times -5, because 3 and -5 both came last. Now that we've done row 1 times the first column, we need to take it times the second column. 2 times -4, because they both came first, 2 and -4, plus, because it's always plus. 3 is last in its row, and 2 is last in its column. We're done with row 1. We now need to go to row 2. We know we're done with row 1 because we multiplied it through all the columns of the blue matrix, the second matrix. So now we're going to take row 2 times column 1. We're going to have 6 times 1, because they both came first. Again, we're multiplying row 2 times column 1. Plus, because it's always plus, 0 times -5. And again, make sure that the numbers in the parentheses, and in this case, the blue numbers, line up. If they didn't, something went wrong. We're done with row 2 times column 1, so now we need to do row 2 times column 2. Starting out, we're going to have 6, which came first, times -4, the first entry in that second column, plus, because it's always plus, 0, which came last, times 2, which came last in its column. And remember that the blue numbers or the numbers in parentheses need to line up. If they didn't, go back, fix the error. Now let's do the arithmetic. In the top left corner, row 1, column 1, where we have 2 times 1 plus 3 times -5, we should get -13. Going across the top row, row 1, column 2, we have 2 times -4 plus 3 times 2. You should get -2. Bottom left, row 2, column 1. 6 times 1 plus 0 times -5 is 6. Second row, second column. 6 times -4 plus 0 times 2 gets us -24. We just found B times A. And notice that B times A does not equal A times B. Because when we took A times B, we wound up with -22, 3, 2, -15. We know that AB and BA aren't equal because they're not the same matrix. -22 is not the same thing as -13 in row 1, column 1, top left corner. 3 is not the same thing as -2 in row 1, column 2, top right corner. None of the entries are the same, even though they have the same dimension, the same order. So again, order of your multiplication matters. Make sure you pay attention to which matrix comes first. And that's what it asked us to do in the label. Again, these labels you don't have to do, it just tells you what you need to multiply.